Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing bedtime astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. This week in astronomy, rare black hole, moonbound telescope, and interstellar object. Rare black hole caught feeding on a star. Scientists using NASA's Hubble Space Telescope and Chandra X-ray Observatory may have found a rare type of black hole, called an intermediate mass black hole, IMBH. This candidate, named NGC 6099 HLX1, seems to be located inside a dense cluster of stars at the edge of a large elliptical galaxy known as NGC 6099. Back in the 1990s, shortly after Hubble was launched, astronomers discovered that most galaxies have supermassive black holes in their centers, with masses millions or even billions of times greater than our Sun. They also learned that galaxies contain many smaller black holes, formed when massive stars die, usually weighing less than 100 times the mass of the Sun. However, black holes that fall between those extremes, intermediate mass black holes, are much harder to detect. These IMBHs weigh between a few hundred and a few 100,000 times the mass of the Sun. Unlike supermassive black holes, they don't consume gas and stars as aggressively, so they don't emit bright radiation all the time. That makes them nearly invisible unless they're caught in the act of feeding, like when a star wanders too close and is torn apart in what's called a tidal disruption event. That kind of violent feeding produces a sudden burst of energy, which we can detect. This seems to be what happened with NGC 6099 HLX1. It lies far from the center of its galaxy, around 40,000 light-years out, and the galaxy itself is about 450 million light-years away in the direction of the constellation Hercules. Chandra first noticed the bright X-ray source in 2009, and scientists tracked its changes over time using another space telescope, XMM Newton. One of the researchers, Yi-Chi Chang, said that very bright X-ray sources outside galaxy centers are rare and may be the key to finding these hidden IMBHs. They're considered an important missing link between small black holes and the massive ones found in galaxy cores. The radiation coming from HLX1 is extremely hot, around 3 million degrees, which matches what we expect from a tidal disruption event. Hubble also found that the black hole sits inside a very compact cluster of stars, where stars are packed so closely that they're only a few light-months apart. This means the black hole could have plenty of fuel to keep feeding. The black hole reached its brightest point in 2012 and then slowly dimmed through 2023. Since the optical and X-ray observations weren't taken at the same times, it's tricky to say exactly what happened. The black hole may have destroyed a star and created a disk of hot gas around it, which sometimes flares up as gas falls inward. Another researcher, Roberto Soria, explained that the brightness changed dramatically over the years, from fairly bright in 2009, to 100 times brighter in 2012, and then fading again. This raises questions about whether it will flare up again or just continue to fade away. This IMBH is far from the center of its galaxy, where a much bigger black hole is likely sleeping and not actively consuming anything. That difference between the center and the outskirts is interesting because it gives clues about how black holes grow over time. One theory says that IMBHs are the seeds from which supermassive black holes grow. As galaxies merge over time, their central black holes could merge too. Hubble has shown that the mass of a galaxy is related to the size of its central black hole, supporting the idea that black holes grow as galaxies grow. It's possible that galaxies contain many IMBHs orbiting in their outer regions that don't always fall into the center. Another theory suggests that in the early universe, dense clouds of gas and dark matter halos may have collapsed straight into huge black holes, skipping the formation of stars altogether. The James Webb Space Telescope has found very distant black holes that seem too big compared to their galaxies, which might support this idea. But there's also the chance that we're only seeing the biggest black holes because smaller ones are too faint to detect at such great distances. These different theories may both be true in different situations. Some black holes might grow slowly over time by eating stars and gas, while others might form rapidly in the early universe. To really understand how black holes grow, scientists hope to find more IMBHs like HLX-1. That means catching more tidal disruption events where a black hole suddenly lights up while eating a star. The challenge is that telescopes like Chandra and XMM Newton look at small parts of the sky, so they don't catch many of these rare events. But a new telescope in Chile, the Vera C. Rubin Observatory, will scan the entire sky and might catch more of these black holes in action. Then Hubble and Webb can zoom in to study them in more detail. Moonbound telescope aims to unveil cosmic dark ages. Scientists in the US have built a special radio telescope called LuSEE-Night that will be sent to the far side of the moon. This is a very difficult place to put any equipment because it gets extremely cold and dark for 14 days, then extremely hot and sunny for 14 more days, with no atmosphere to protect from radiation. But it's also the quietest place in terms of radio waves, which makes it perfect for listening to faint signals from space, especially signals from the early universe. This project is being led by Brookhaven National Laboratory and the Space Sciences Laboratory at UC Berkeley, along with help from other labs. The main goal is to detect radio waves from a time called the Dark Ages, which happened about 380,000 years after the Big Bang, before stars or planets had formed. These ancient signals are blocked on Earth because of all the radio noise from our planet and the Sun, but the far side of the Moon is shielded from all that noise. The telescope had to be carefully designed to be small and light enough to launch, but also strong and smart enough to survive and work on the Moon. The most important part is its spectrometer, built at Brookhaven, which can detect and process very faint radio signals. It works like a super-sensitive radio that can hear all frequencies at the same time. It can also adjust itself and reduce its own noise to avoid interference. This makes it much more powerful than similar instruments that can only capture a small amount of data at once. Power was one of the biggest challenges. Since the Moon has long nights with no sunlight, the telescope has to rely on a battery to stay alive and keep working. The battery itself is heavy, so they had to balance its size with the total weight of the telescope. The team also designed a special cooling and heating system to keep the telescope from freezing or overheating during the extreme moon conditions. This includes things like heat pipes and thermal switches, which work like a thermostat. Even though the goal is to run LuSEE-Night for up to 2 years, the team knows the first lunar night will be the real test. To prepare, they're running simulations here on Earth to practice controlling the telescope and analyzing the data. They've also updated the plan so the telescope will send small amounts of data earlier than originally intended, just in case it doesn't survive the first night. LuSEE-Night isn't just about gathering data, it's also meant to prove that it's possible to do radio astronomy from the Moon. If it works, it could lead to more missions like this in the future. The telescope is scheduled to launch in 2026 aboard a lunar lander. The team is excited and hopeful, seeing this as the beginning of a new chapter in space science. Strange interstellar object 3I/Atlas baffles scientists. On July 1st, astronomers noticed something unusual, a fast-moving object heading toward the Sun. This object was called 3I/Atlas. What made it so interesting was that its path through space showed it had come from outside our solar system. Only 2 other objects like this had ever been seen before. That made 3I/Atlas a rare and special find, an interstellar visitor, meaning it had traveled through the space between stars before arriving here. What also made 3I/Atlas stand out was how fast it was going. It was moving at an incredible speed of about 245,000 kilometers per hour, faster than anything else we've ever seen in the solar system. On top of that, scientists think it might be very large, possibly up to 20 kilometers across, and maybe even older than our Sun, which is more than 4.5 billion years old. Whenever scientists see something new in space, the first guess is usually that it's made of rock or ice. But 3I/Atlas is strange enough that some researchers are wondering if it could be something more unusual. One scientist, Avi Loeb from Harvard, even raised the idea that it might not be natural at all, that it might actually be alien technology. He and his team posted a paper online suggesting this, although the paper hasn't yet been officially reviewed by other scientists. Loeb is known for making bold suggestions like this. He also previously said that another object called 1I/Oumuamua, which passed through the solar system in 2017, might also have been a spacecraft sent by an alien civilization. In the case of 3I/Atlas, Loeb pointed out that its path takes it unusually close to planets like Venus, Mars, and Jupiter, a detail that caught his attention. The idea of alien probes traveling through space might sound like science fiction, but humans have already done something similar. In the 1970s, we launched spacecraft like Voyager 1 and 2, and Pioneer 10 and 11. These have now left or are close to leaving our solar system. So if other intelligent life exists out there, it's not a crazy idea that they might also send out robotic explorers. But this raises a big question: if an object like 3I/Atlas were a probe sent by aliens, how could we possibly know? It's not easy. Most of the things we detect in space don't give off light themselves. We only see them because they reflect sunlight. Big objects reflect more light and are easier to see, especially if they're far away. But smaller objects, like one the size of a spacecraft, are very hard to spot unless they get relatively close to Earth. If we did find something suspicious, scientists would look for clues to figure out if it's natural or artificial. A natural object like a comet might leave behind a trail of gas. But if it were a probe, there might be other signs, like radio signals being sent out, especially if the probe were still functioning. We might also notice weird flashes of energy caused by sunlight hitting metal surfaces. A really strong clue would be if the object seemed to be steering itself, changing direction, adjusting its position, or doing something that suggests it was under control. And the biggest sign of all would be if it came into orbit around Earth. That would make sense if the object was curious, since Earth has liquid water, a breathable atmosphere, a magnetic field, and life, things that would definitely interest any alien science mission. Still, unless we find one of these clear signs, it's hard to say for sure whether something like 3I/Atlas is natural or not. It's probably just a very old, very fast object made of ice or rock that's been traveling through space for billions of years. But it's strange enough to keep scientists watching closely. Each object like this teaches us more about how to search for the truly unexpected. Even if 3I/Atlas isn't an alien probe, it gives us a chance to improve the way we study space, and to stay alert for anything that might turn out to be more than just a rock.